From here on Earth, our sun looks steady and unchanging. But close up, it's a dynamic, active place. If you had X-ray vision, you'd see loops of superheated plasma following tangled magnetic fields across the surface, and a steady stream of electrically charged particles expanding into space in all directions, the solar wind. And sometimes you'd see bursts of radiation called solar flares, and explosions of plasma and magnetic fields called coronal mass ejections erupt from our star's surface, sending solar storms racing off into space through the solar wind. Here on Earth, we live in that solar wind, in the atmosphere of our star. Its interaction with our planet's protective magnetic field causes the aurora borealis. But when the coronal mass ejections hit Earth, our magnetic field can go haywire in what's called a geomagnetic storm. Powerful electromagnetic currents generated during these storms can harm our power grids, global positioning systems, communications networks, and spacecraft and astronauts on orbit. In 1859, during a particularly strong solar storm known today as the Carrington event, some telegraph operators realized they could still send messages with the power turned off. Geomagnetically induced currents generated by the storm knocked out telegraph lines completely and even sent sparks flying off the wires. Today, our technology-dependent world runs on a far more extensive electrical infrastructure than in 1859. This makes us vulnerable to the impacts of space weather. A storm in 2003 caused power outages around the world and even destroyed a satellite. Because of the tremendous potential for impacts to infrastructure, NOAA constantly monitors the sun's activity, keeping an eye out for potentially hazardous space weather.